Hello everyone, I welcome you all to Keralakkam CBSE School Module online classes. In previous class we completed exercise 8.1. So before starting exercise 8.2, we will discuss one theorem, theorem 8.9. Theorem 8.9. What they have given here? The line segments joining the midpoints of two sides. Here I write the line segment, the line segment joining the midpoints joining the midpoints of two sides of a triangle is of a triangle is parallel to third side, parallel to third side. The line segment joining the midpoints of two sides of triangle is parallel to third side. So here I will consider this diagram. Triangle A B C, and here in this triangle the line segment joining the midpoints of two sides. Here midpoint of AB and midpoint of AC. I will name it as E and F. The line segment joining the midpoints of two sides. The line segment joining midpoints of these two sides of a triangle is parallel to third side. Means we have to prove this EF is parallel to BC. Why? This E and F are midpoints of AB and AC. Therefore, this the line segment joining these two midpoints is parallel to third side, means EF is parallel to BC. We have to prove that. Even this is known as midpoint theorem. This is also known as midpoint theorem. So this is very important theorem in 8th chapter. And here, what they are given here? Given. First, I will write what they are given. ABC is a triangle. ABC, this ABC is a triangle where E and F are midpoints of AB and AC. Where E and F are E and F are, what are those? Midpoints of this AB and AC, right? And this is given. Next, we have to prove here. What we have to prove? The line segment joining these two midpoints E and F. What is the line segment? EF. That is parallel to third side means BC. So we have to prove here. We have to prove what we have to prove is EF is parallel to BC. EF is parallel to BC. Now, for this to prove EF is parallel to BC, we will construct here construction. What we will do? Through this point, through C, draw a line segment from this point C, draw a line segment parallel to AB. Through this point C, draw a line which is parallel to AB and extend EF. First I will draw one line from through C which is parallel to AB. So this is the line through C which is parallel to AB, and here we should extend this EF. We should extend EF to meet at D. So here we will extend this EF to get point D. So what we did here in construction, through C, point C, draw a line segment parallel to, draw a line parallel to AB, parallel to AB, and again what we did here, extend EF. We extend EF to get point D. Extend EF to get point D. So now here proof. What we have to prove? This EF is parallel to BC. We have to prove. Now, to prove that here this EF is parallel to BC, by construction, here by construction, we know that this CD is parallel to AB. Why? See here, through C, from this point to C, draw a line segment parallel to AB. Therefore, this CD is parallel to EB by construction. Here, these two sides are parallel. CD and EB are parallel here, and extend EF to get point D. This is by construction. What we know, these two sides are parallel, and we have to prove here these two sides are parallel. Means BC and EF are parallel. We have to prove. If we prove this is a parallelogram, if we prove this BEDC is a parallelogram, by that we can say opposite sides are parallel to each other. Then we can prove BC is parallel to EF or AD. To prove that, what we know by construction, EB is parallel to CD by construction, and if we prove that these two sides are equal, means these two sides of parallelogram are equal or quadrilateral, these two sides are equal, then we can say this is a parallelogram. Therefore, if it is parallelogram, these two sides are also parallel to each other. So first, here what we have to prove? These two sides are equal, because by construction we know that these two sides are parallel. These two sides are parallel now. Now again, if we prove these two sides, listen carefully, if these two sides are equal, then by theorem what we know, if these two sides are equal and parallel, then this is a parallelogram. If any two sides of a quadrilateral are equal and parallel, here, if any two sides of parallelogram are equal and parallel, then we can say that that is a parallelogram. And if we prove this is a parallelogram, these two sides are also parallel. So now, by construction, we know that these two sides are parallel. These two sides are parallel because we constructed a line through C which is parallel to AB. Therefore, these two are parallel now. But we have to prove these two are equal also. So now, to prove these two sides are equal, what we will do? First, I will consider two triangles here, AEF and CDF. I will consider these two triangles. I will mark here. AEF and CDF. Why? If we prove these two triangles are congruent, if these two triangles are congruent, then we can say these two sides are equal. Listen carefully. If these two triangles are congruent, then these two sides are equal because of CPCT. Corresponding parts of congruent triangles. These two sides are equal. And we know that this E is midpoint of AB. Therefore, these two sides are also equal. So now, if these two sides are equal and these two sides are equal, then you can say these two sides are also equal. So if these two sides are equal and parallel to each other, then we can say BEDC is a parallelogram. So see here. First I will consider triangle AEF and DCF. In triangle AEF and triangle AEF and CDF. And here, first what we can write here? We know that this F is midpoint. In question only they have given, and here we have written E and F are midpoints. Therefore, this F is midpoint. So now we can write EF is equal to FD. Sorry, AF is equal to FC. Here, this F is midpoint of AC. Therefore, AF is equal to FC. AF equals to FC, because what is the reason? F is midpoint of AC. That they are given in question only. This F is midpoint of AC, therefore F is equal to FC. So now again, here these two angles are equal. These two angles, because vertically opposite angles, these two angles are vertically opposite angles. Now we can say that angle AFE is equals to angle CFD. Angle AFE equals to angle CFD. Angle CFD. So now, why these two are equal? These two are vertically opposite angles. So now these two angles are equal. Again I will consider now these two angles here, this angle and this angle. Why? We know that this CD is parallel to AB by construction, and this is the line of intersection or traversal line. Therefore, these two are alternate interior angles. Therefore, these two angles are equal. Therefore, AEF angle AEF, this angle is equals to angle FDC. Angle FDC. Why these two angles are equal? Because of alternate interior angle. Why these two angles are alternate interior angles? Here, this CD is parallel to AB. Therefore, these two are alternate interior angles. Now, here two angles are equal and one side is equal. Therefore, what we can write here? These two triangles are congruent by angle side. Therefore, triangle AEF is congruent to triangle CDF by angle side. Yes. These two triangles are congruent now. These two triangles are congruent. Then we can say that these two sides are equal. CD is equals to AE. What we can write here? CD equals to AE. Therefore, CD is equal to AE by CPCD. CPCD means you know that corresponding parts of congruent triangle. Therefore, this CD is equal to AE. So here, I will consider this as 100. So now we got to know this CD is equal to AE. Again, we know that this AE is equal to BE. AE is equal to BE. Why? Why A is equal to B? This E is midpoint. Therefore, why these two are equal? B is midpoint of side AB. So I will consider this as 2. Now, from 1 and 2, what you can write here? From 1 and 2. Here also CD is equal to AE and here also A is equal to B. So these two are equal to AE only. Therefore, from 1 and 2, you can write CD is equal to B. CD is equal to B. So we prove this CD is equals to BE. Already we know that CD is parallel to BE and now we prove this CD is equal to BE. Therefore, in quadrilateral BEDC, in quadrilateral BEDC, what we got to know now? This CD is parallel to B or B is parallel to CD, and by construction we know that this B is parallel to CD and B is equal to CD. We got to know B is equal to CD. Here we proved that this B is equal to CD. And we know that if in a quadrilateral, in one quadrilateral, one pair of sides are equal and parallel. If one pair of opposite sides, if one pair of opposite sides are equal and parallel, then we can say that that quadrilateral is parallelogram. Therefore, here one pair of opposite sides are equal and parallel. Therefore, we can consider as this is a parallelogram. So here I will write therefore BECD or BEDC is a parallelogram. Why it is parallelogram now? So if in a quadrilateral one pair of opposite sides are equal and parallel, then that quadrilateral is parallelogram. So now here I will write. So now what they have given? BDC is a parallelogram, but here we have to do these two are parallel. If this is a parallelogram, BEDC is a parallelogram, then we can write if this BDC is a parallelogram. Next step we can write BC is parallel to ED. BC is parallel to ED. Now, and we can write BC is also equal to ED. Why? You know that in a parallelogram always opposite sides are parallel and equal. Therefore, now we proved BDC is a parallelogram. Now we can write this BC is parallel to ED. So we proved this is parallel to BC and this BC is equal to ED. So with this theorem only in exams they can ask to prove this EF is equals to with this they can ask to prove in this question only EF this EF is equals to half of the BC. This EF is equals to half of the BC. To prove that, what we can do here? We know that BC is equal to ED because opposite sides of parallelogram. And ED means EF plus FD. Why? This F is midpoint. So here we can write BC is equal to EF plus FD. And to get EF value, we can write BC is equal to EF plus EF. Here in the place of FT, we can write EF also because F is midpoint. Therefore, BC is equal to ED means BC is equal to EF plus FT. Here, EF plus FT. In the place of FT, you can write EF because EF is equal to FT because F is midpoint. So now we got BC is equal to EF plus EF means 2EF. Now what we can write here? I will move this 2 to other side. Therefore, EF is equals to. When I move this 2 to other side, it becomes denominator. Therefore, 1 by 2 into BC. Therefore, EF is half of the BC. If they ask this, if EF is equal to 1 by 2 into BC, then you have to prove this. So this is the theorem called as midpoint theorem. What is this? Listen carefully again. So here line segment joining the two midpoints. These two midpoints is parallel to third side means BC. So they are given ABC is a triangle and here EF are midpoints of AB and AC. So we have to prove this EF is parallel to BC. This is given and we have to prove EF is parallel to BC. And next construction here we have to construct or draw a line through point C in such a way that this line should be parallel to AB. And we have to extend this EF to get to point D. So this is the construction. Next we will start proof. So here to prove these two sides are parallel, what we know first? These two sides are parallel by construction. EB is parallel to CD by construction, and if we prove these two sides are equal, if these two sides are equal, means First only we know by construction these two sides are parallel also, and we know that in a quadrilateral, if one pair of opposite sides are parallel and equal, then we can say that is a parallelogram. So if we prove these two sides are equal, how to prove this? To prove this means to prove these two sides are equal, we will consider these two triangles first. Here we consider these two triangles. So here these two sides are equal because f is midpoint, and these two angles are equal because of vertically opposite angles. These two are alternate interior angles. Therefore, these two triangles are congruent here. If these two triangles are congruent, then these two sides are equal. Now, if these two triangles are congruent, then you can say these two sides are equal because of CPCT, corresponding parts of congruent triangles. And we know that this E is midpoint of AB, therefore these two sides are equal. So here we get first and second. This is second, A is equal to BE. So now by these two, what we can write from 1 and 2, these two sides are equal. So if these two sides are equal, by construction we know that these two sides are parallel also. So therefore in a quadrilateral BEDC, these two sides are parallel by construction, and we prove these two sides are equal, then we can say that this BEDC is a parallelogram. Here we have written. So if BEDC is parallelogram, we prove that these two sides means BC and ED are parallel to each other. So here this BC is parallel to ED, and we can write this BC is also equals to ED, because in a parallelogram opposite sides are equal and parallel, therefore BC is equal to ED. Hence we prove these two sides are parallel. So if they have given this EF is equal to half of the BC, you have to consider this BC is equal to EF plus FD, and we know that FD is equal to EF, therefore in the place of FD you can write EF plus EF. So 2EF is equal to, we can prove EF is equal to 1 by 2 into BC. So what we have to remember here, you have to prove these two sides are equal, because you know these two sides are parallel, but you have to prove these two are equal. To prove this, first we will consider these two triangles, so that you can prove these two sides are equal and these two sides are also equal. So you can prove these two sides are equal. So by using this, you can prove this is a parallelogram. If this is parallelogram, then these two sides are parallel to each other. I hope you all are clear with this theorem. Next class, I will continue with further problems. Thank you all.